Hello friends, welcome to this video. So here also we are going to solve a question which was asked in JEE Mains 2021. So let me read the question, then we will discuss about its solution. So the question is, an X-ray tube is operated at 1.24 million volt. What will be the shortest wavelength of the produced photon? Okay. So an X-ray tube which is operated by this much voltage, okay, 1.24 million volt, quite high voltage. So in that case, what will be the shortest wavelength of the produced photon? Photon means X-ray photon, okay, X-ray tube. So photon means it's the elementary particle which makes up electromagnetic radiations. Okay, electromagnetic radiations like X-rays. So we have to calculate the shortest wavelength of the X-rays. Okay, in other words, we have to calculate the shortest wavelength of the X-rays. So let me share my screen for the solution. Okay, so we'll solve the question here. So we are given the voltage. Okay, the voltage is 1.24 million volt. Okay, million million volt. That means it is 1.24 multiplied by 10 to the power 6 volts. Okay, 1 million means 10 to the power 6. So we have to calculate the shortest wavelength. Okay, what is the shortest wavelength that we shall have to calculate? Okay, shortest wavelength. Okay, so how we can calculate the shortest wavelength, the wavelength in this case? So for that we need to understand what is the expression for energy and wavelength. Energy and wavelength. So this is the expression for energy and wavelength. Okay, energy supplied and wavelength. If you supply this much of energy, so lambda would be the wavelength, hc divided by lambda. Okay, so what will be the expression for lambda only in the wavelength? That would be hc over e. Okay, hc over e is the energy. That would be the expression for wavelength. Now, are we given the value of E, the energy? No, we are not given the value of energy. So how we can calculate the value of E, energy? Energy is equal to electron charge multiplied by the applied voltage. Okay, so this is the expression for energy. Okay, so how we can calculate it then in that case? So you have to remember this relation: energy is equal to electron charge multiplied by the applied voltage. So electron charge is 1.6 minus 10 to the power minus 1.6 multiplied by 10 to the power minus 19, and V is given here 1.24 multiplied by 10 to the power 6. Okay, this is here 1.24. So energy is this much of this much of joule. Okay, so now substitute the value of energy here. So here what quantities we have? We have h means Planck's constant, which has got a value of something like this: 6.63 multiplied by 10 to the power minus 34, multiplied by c. C is the speed of light. It is 3 multiplied by 10 to the power 8 divided by E, energy, which is 1.6 multiplied by 10 to the power minus 19 multiplied by 1.24 multiplied by 10 to the power 6. So meter. Okay. So the energy, so the expression for wavelength will be simply in meters, okay, because we are expressing everything in the SI unit. So now just do the multiplications. So 6.63 multiplied by 3 divided by 1.6 divided by 1.24. So that would roughly give us 10.02. Okay, if you do the calculation, you will get that to be 10.02. So here 10 to the power minus 34, 8, minus 19 and 6. So how much will we get? So it will be 10 to the power 2 to 10 to the power minus 32 minus 19. So that would give us 10 to the power minus 13 minus 13 meter. Okay, so now you can further simplify this expression of wavelength. Okay, so wavelength is equal to 10 multiplied by 10 to the power minus 19 meter approximately. Okay, 10.02 in place of 10.02 we can write it as simply 10. So lambda again. So wavelength is generally expressed in, if you have seen, wavelength is generally expressed in two units. One is angstrom and the other one is nanometers. Okay, if you so what if we express the wavelength in angstrom, 10 to the power minus 3, 10 to the power minus 10 meters. Okay, so wavelength will be 10 multiplied by 10 to the power minus 3 is equal to 10 to the power minus 2, and 10 to the power minus 10 meter means 1 angstrom. So wavelength is 10 to the power minus 2 angstrom. Okay, or how we can write this? We can write this as 10 multiplied by, we can write here this expression as 10 multiplied by 10 to the power minus 4 multiplied by 10 to the power minus 9 meter. So 10 multiplied by 10 to the power minus 4 is 10 to the power minus 3, and 10 to the power minus 9 meter is 1 nanometer. So we can write wavelength as 10 to the power minus 3 nanometer. So both values of wavelength are correct. So 10 to the power minus 2 angstrom or 10 to the power minus 3 nanometer. Okay, so this would be the shortest wavelength of the X-ray photon. Okay, shortest wavelength of X-ray photon that would be generated upon the application of 1.24 million volt. Okay, so let us revise this question again. So expression for energy is this: hc over lambda. Lambda is hc over E. So h and c values you substitute. Energy value you can get from here. Energy is electronic charge multiplied with the applied voltage. So this will be the energy value. Substitute here, do the calculations, and then we will get these expressions for wavelength. So friends, I hope you have understood the solution, and please like the video, subscribe to this channel. Thank you very much for watching, and I will meet you in the next video. So thank you very much.